The crate slid off the truck bed and thumped into the naval arsenal yard. The men watching did not cheer. They did not clap. They stood around it with the quiet that follows the smell of old grease and crate wood. Someone cut the wire. Someone pried the floating lid. Under the straw lay a rifle that every man in that yard had heard about for years. It was the American service self-loading rifle with the short name that felt like a challenge. M1. The men did not photograph the moment. They did not pose. They lifted the rifle out and held it like a textbook printed in steel. They turned it over and over. They spoke in short sentences. Look at the op rod. Look at the cam cut. Look at the gas cylinder. Look at the bolt lugs. The rifle did not care who looked. It had fed and fired in cold and in mud. It had been made by the tens of thousands. The men in the yard wanted a rifle that could do the same job with the parts they had. They wanted something they could teach to factories that were already tired. They called the goal simple. They wanted Garand performance without American factories. They wanted a pattern that their own workers could copy. They wanted a rifle that fired the Japanese service cartridge. They wanted a path that led from bench to line before the war ended the question by itself. The path looked clear on paper. A gas-operated action, a rotating bolt, an internal magazine that held many rounds at once, a method to load it fast under stress, sights that a conscript could read, a stock that the machine shops could fit without a pile of hand files. The path was not clear in steel. Men at Yokosuka Naval Arsenal pulled the American rifle down until the table looked like a parts list had spilled. They learned the order by feel. They cleaned parts that did not need it just to see how the finish bit into the steel. They measured every face. They traced each curve on thin paper. They filled notebooks with the places where one surface kissed another. They asked obvious questions. Where does the gas go? How much does the spring fight? How does the follower climb? How does the clip lock and leave? They had a second question that was less polite. Which of these tricks can we do in a factory that is cold and hungry? An officer brought a coffee can full of the Japanese service cartridges. He set the can down and looked at the pile of American en-bloc clips on the table. He picked one up and tried to push the Japanese cartridges into it. He worked with the clip at many angles. He frowned. Someone else tried. Finally, the officer set the clip down hard enough to rattle the table. The American clip and the Japanese cartridge did not like each other. The dimensions were wrong in small ways that mattered. The rim, the taper, the precise distance between the shoulders. The clip had been made for a cartridge with a shape that was not this one. It could be forced to work with careful hands on a bench. It would not work with cold fingers in a trench. The team wrote that down. They drew a line through the idea of living with the American clip. They drew a second line under the idea that they must feed their own cartridge in a way that their troops understood. So they moved to a solution that had a Japanese accent. They kept an internal magazine. They gave it room for 10 rounds. They designed the opening to accept 2 5-round stripper clips from the top. Men who had learned to jam 5 rounds down into an Arisaka magazine could now do the same thing twice. The American rifle spat the clip on the ground when empty. The Japanese copy did not. It held the follower down against a spring. It waited for hands and for another pair of clips. It looked like progress. It also sowed seeds for a crop of small pains later. The choice would haunt the test range in ways that felt unfair. It would also be fair. Machines do not care what we mean. They care what we build. The record today is clear that the Japanese design kept the 10-round fixed magazine with 2 5-round stripper clips rather than the American en-bloc clip, while the rest of the action followed the American pattern with a Japanese sight and furniture. That choice shows up in every serious summary of the rifle. It shows up in range notes and in captured reports. It shows up in museum placards that still say the same few lines after many years. They pushed forward anyway. They had to. The date on the wall did not move backward for anyone. The rifle design work picked up speed in late 1944. The calendar name of the project created confusion that still hangs on the rifle today. The official name marked the year as Type 4. American intelligence papers misread it and passed around the name Type 5. That wrong tag stuck in reports and in later books. A man can still walk into a museum and read the wrong tag near the glass. He can still find both names in the same folder. They kept the gas-operated heart. A poured blood pressure into a cylinder. A piston moved an operating rod. The rod ached to bend if you cut corners. The bolt rotated. The lugs locked. The cam track demanded the smooth slide that only good steel and careful heat treatment can give. Every surface that rubbed wanted oil. Every surface that held back pressure wanted a heat treatment curve that did not lie. The men at the bench could make one rifle breathe. They could make 5. They could make 10. They could fit each one like a watch. They could stone and polish and move burrs with a scribe until the bolt grew slick. They could change spring rates and try again. A factory cannot do that at scale when the lights flicker and the scrap bins are full. A factory needs a process that forgives. The first test rifles went to the range behind a low berm. They loaded 10 rounds from the top. They took a breath. They fired slow. The first string sounded like a plan coming to life. The bolt cycled. The brass flew and bounced in the dirt. The follower rose a few steps. Then a case stuck. The extractor snapped off a shard that looked like a tooth. The bolt tried to run home on a case that was not gone yet. The men looked down and did not speak. They made notes. They changed small things. They polished feed lips. They changed the spring in the follower. They moved the feed path a hair. They turned a new extractor from the best steel the storeroom had. They went back to the berm. The next string looked better for 7 rounds. Then, a bolt over base failure wrote a diagonal scratch on a fresh case. The bolt closed on an empty chamber, while the magazine still held ammunition. Someone cursed, and then wrote a neat line that said failure to feed, 8th round, follow a lag. The men did not offer a speech about destiny. They drew, they measured, they cut. They tried again. The pattern of pains kept returning. Light springs could not lift the stack fast enough if the rifle was dirty. Heavy springs made the last 2 rounds, tried a nose dive. A magazine body that was a shade narrow would bind and never tell anyone until the 10th minute of a wet fight. Silently into the city of Naples, the extractor needed a bite that was just right and could be counted on by any bolt that came off any machine in that month. The ejector needed a throw that cleared the mouth of the case at many speeds. The gas short stroke that a clean rifle masked became obvious when range dust sat on oil. The rifle was a teacher with a cane. The Yokosuka men sent word that they needed help. The plan moved production away from the arsenal and toward a private firm in Aichi Prefecture. Washino Kikai took the drawings and tried to bench work into line work. The program brought a hope that felt like bravado. It had also brought a set of problems that do not bow to hope. Parts breakage during testing. Marginal impulse in a rifle that weighed what it weighed and asked for a gas curve that was not always there. Feeding problems that came and went with lots of ammunition and with slight changes in surface finish. The internal reports used plain words. They used the words that any shop uses when a machine is not yet honest. Parts breakage, insufficient recall energy, feeding faults. The most complete English language retellings include those exact phrases. The move to Washino is also there. The sum is not a secret. The numbers at the end of the war tell their own story. The plan asked for hundreds. The racks held parts for a figure near 200 by mid-1945. The assembly benches finished perhaps 125. Allied teams took a score of completed rifles from Yokosuka after the surrender. The rest stayed where they were. Some rifles went to back rooms. Some went to museums. A few moved in auction catalogues and surprised bidders with prices that reflected what a rare odd history piece can command. These same counts appear across independent sources that do not share a common gossip line. The details are steady and have been steady for years. Now stop and place your hands on the thing itself. The woodstock feels familiar to anyone who has handled an Arisaka. The sling hardware is Japanese in shape. The rear sight is a tangent rather than an aperture. The bolt lugs lock with the same short, smooth move as the American pattern. The op rod rides in a window that looks like the American pattern at a glance. The magazine is deep and permanent. The loading slot at the top says that doctrine has a seat at this table. A test team fires the rifle again. This time, they run it through drills that look like a training course. They load 10 rounds in 2 strokes. They fire a string at a steady cadence. The rifle cycles with the sound that a gas-operated rifle makes when everything aligns. The brass flies and draws neat arcs. Then, the group runs a prone drill with dust in the wind. The rail inside the receiver that guides the bolt picks up grit. The ammo lot on the table is not all from the same press. The powder burn is not the same in every case. The rifle begins to act like a machine that wants forgiveness, and will not always get it. The old Arisaka bolt action on the next bench acts like a plough. It does not care about grit as much. Its extractor is a simple hook that could pull a case out of a rusted chamber. The magazine has fewer ways to lie. The spring can be dirty and still lift. The bolt body can scratch and still close. That old pattern was not better for volume of fire. It was better for a factory that could not meet tighter toll gates in every room. It belonged to the time that the men now stood in. Engineers know that a design that needs tight tolerances is not wrong by itself. It is wrong when the shop cannot hold them all day. A rifle that demands clean spring steel and precise heat treatment needs a shop that does not run out of gas for the ovens. It needs tool steel that has the right chromium and carbon. It needs cutters that hold an edge for more than a few dozen parts. It needs gauges that stay true even when the weather changes. The men in Japan at the end of the war did not have that shop every day. They had skill. They did not have the room to breathe. The American rifle grew up in a very different house. It came to life in a program that could lean on mass forging, on reliable alloy supply, on machine tools that held a line for months, and on an inspection culture that threw parts back into the scrap bin without apology. It lived with fuel. It lived with raw bar stock that matched to spec. It lived with trained labor that had eaten enough. It lived with time. When you copy a design, you also copy its demands. You cannot negotiate those demands with a drawing. The feed angle that looks fine on paper needs a magazine that is stamped and bent within a band that is not very wide. The cam curve for the bolt wants a cutter that does not wander across 3 shifts. The op rod wants to be a shape that resists bending and binds only when you do not polish the slot. The gas port wants a diameter that does not drift down because the drill bit was dull. The heat treatment wants a quench and a temper that look like a small religious ritual. Deviate and the steel will tell on you. The test course wrote these rules in scars on stocks and in broken extractor tips. The notes piled up. Operators wrote the same 2 words again and again. Stoppage. Jam. The stoppages were not the same every time. Some were feed path stalls that happened when the follower lagged half a round behind cadence. Some were failures to extract when a case expanded too hard and the chamber had a place where a cutter had left a ridge. Some were short strokes that a strong spring hid when the rifle was new, and that came back once the spring tired only a little. The gas system was not a villain on its own. It was a worker that confronted a load that changed every hour. Powder lots were not all equal at that stage of the war. Cartridge cases were not always draw and annealed the same way. The bolt face finish was not always the same. The extractor claw bite depth could change with a cutter that sharpened on Friday and not on Wednesday. Add all that together, and the gas curve could not always lift the load that the bolt and spring set down for it. The rifle asked for a base of metal that was not available and a floor of process control that was not available either. The engineers at Yokosuka and then at Washino tried to push the mountain 1 handful at a time. They hardened extractors and tried to keep them from becoming brittle. They opened gas ports a hair to get more impulse. That brought a new set of pains when the rifle was hot. They changed magazine spring wire and found that the new wire cracked earlier. They opened the feed lips a hair and then saw that now the stack did not control the round during bounce. They cut 1 more relief into the receiver rail, and now the bolt rode smoother in this sample and not in that one. Each change moved a problem rather than killed it. There are notes that suggest a few test rifles went to units for a taste of field life. Those notes do not tell a story of triumph. They tell a story of rifles that worked enough to give hope and then stopped enough to make men speak careful words. A prototype can charm in a calm hour. A service rifle must serve when nothing is calm. The small number of rifles that left Yokosuka gave more questions than answers. The wider plan asked Washino to build and solve the pain with practice. There was no time. There was no steel to waste. There were more urgent demands on every machine. The end came in the simple way that most projects end in war. The news from the coast was bad. The news from the skies was worse. The rail cars that carried parts did not always arrive. The men at the benches were called away to different work. The arsenal lights did not burn late every night. The program did not get a last meeting. It just stopped. The war answered the question for them. After the surrender, teams from the other side walked the floors at Yokosuka. They looked at the benches and the racks. They picked up rifles that had the wrong name stamped into them. They wrote down numbers. They took a few dozen rifles away and placed them on tables in rooms far from where they had been born. Those rifles now lay behind glass in a country that had made the pattern first. Many labels still use both names on the same day. A museum tag will say Type 4. A collector list will say Type 5. The story behind the tag is the same in every retelling that is careful. The rifle was a serious copy of the American pattern with Japanese choices for loading and sights. It did not become a service piece. It stayed a study. If you lay a Type 4 or Type 5 on a bench next to its American parent, the family link is easy to see. The line from gas pour to piston feels the same move. The pocket, where the bolt rotates into battery, feels like a cousin. The follower in the magazine rises with a stern push rather than a cheerful bounce. The rear sight does not ask the eye to look through a small ring. It asks the eye to read a leaf. The hand that loads 10 rounds from the top feels the long stroke and thanks the old muscle memory from a 5-round life. Now imagine you are the test gunner who must write a plane report. You begin with the good line. Accuracy is acceptable. Recoil is pleasant. The action feels smooth when clean. The weight is well balanced. You move to the line that cannot be avoided. Feed faults were noted with several lots. Ejection faults were noted as the rifle heated. Extraction faults were reduced after chamber polishing. The last 2 faults did not disappear when we used ammunition from the other press. The magazine follower stops shy of full lift when dust is present. You write that report, and you know it does not read like a victory speech. You hand it in anyway. What can a rifle teach after it fails to achieve service status? It can teach what a drawing cannot teach. It can teach that copying a design does not copy an industrial base. It can teach that a gas-operated self-loader wants steel that does not lie after heat. It can teach that a feed system that depends on a stack of rounds rising without delay wants springs and followers and a magazine box that act like friends, even when cut on tired machines. It can teach the social truth that runs under every weapon program in a long war. Production reality is not a note in the margin. It is the main story. A historian will add something else. The project also shows that doctrine walks in when design leaves the door open. The choice to avoid the American clip and to keep a top loading path says more than a paragraph can hold. It says that the user wanted to keep the feel of the old rifle in the new hand. It says that the supply system could not stop and retool a clip that had never lived in those depots. It says that a copy is always a conversation between what the eye sees and what the hand has known for years. Now imagine the alternative path that men in that yard sometimes talked about at the end of a shift. What if they had been able to adopt the clip and make it fit the service cartridge? What if the shops had time to harden extractors the right way for a month in a row? What if the gas curve had been locked down early? What if the range had seen 300 rifles in a month instead of 3 dozen in a season? That path does not exist in the record. The record is the only thing we can use. The numbers in that record are like the footprints of a man who tried to run on soft ground. Parts for something like 200 rifles. A smaller number finished. A handful that went out. A score that the other side collected. Markings that look hand engraved on some receivers. Differences in markings that tell you the process was more workshop than assembly line, even at the end. The sums repeat in the same ranges across separate accounts. The words that ride next to those sums are also steady. Feeding problems, jamming, parts breakage, insufficient recoil, testing delayed, production moved, production stopped. There is a kindness owed to the men who cut steel in that program. They were not fools. They were not careless. They were asked to make a complex machine at a time when the floor under their feet moved. They tried. They produced parts that look good even now. They fit rifles that run when you feed them, the one lot of ammunition that loves them. They made a rifle that gives a collector a thrill when he locks the bolt back and rides it forward. Once, twice, 3 times. That same collector will also admit that he does not take it to a muddy range day and bring a pile of unknown ammunition. He knows what the test range learned the hard way. An engineer will stand by the glass at a museum and explain the lesson in a way that feels dry. The American rifle is not just a design. It is an expression of a factory system. It reflects heat treatment knowledge that lived in furnaces that ran all day. It reflects tooling that matched jigs, that matched gauges, that matched inspection stamps. It reflects an ammunition plant that fed it a diet with small variants. It reflects labor that did not roll away when air raid sirens went off twice a night for a month. The Japanese copy did not live in that house. It lived in a workshop that could sometimes pretend to be a factory. It lived in a time when the best steel was needed for ships and planes, and did not always arrive for rifles. It lived in a world where a magazine box that was supposed to be this wide came out, that wide, after the press wore out. It lived in a time where you could bark at a man to hold tolerance, and he would nod, and then show you his drawer of dull cutters. The failure is not a stain on pride. It is a page in the manual that every country has written in its own way. You can copy a shape. You cannot copy a supply chain with a pen. You can copy a chamber drawing. You cannot copy the exact heat-bland blend that a mill used in a different valley. You can copy a spring dimension. You cannot copy the lathes that turn wire into spring with the same life if the lathes in your town are tired. A simple sentence lives at the end of all that. Copying is not cloning. A clone requires the same bones and the same blood. The Type 4 or Type 5 rifle had the bones of the American pattern. It did not have the blood of the same factory world. That is why it lived as a series of prototypes. That is why a yard worker can look at it and feel both respect and regret. Men who held those rifles at Yokosuka did not write poems about them. They wrote requests for better steel and for more time. They did not get what they needed. A few rifles left the yard and were carried by men who knew that they were carrying test pieces. The wider force marched with bolt guns that had been made for another war. That is not a moral. That is a fact. After the war, the story became a kind of myth with a technical face. Writers called the rifle a Japanese Garand. Some used the wrong name because of a single American report that made a small mistake about the calendar designation. People still argue in small corners of the internet about the correct name. The rifle cannot hear them. Museums use both names in different halls. The real lessons do not change with the tag. The most complete English language accounts repeat the same concrete details when they want to move past the myth into the file. They say the design work began in 1944. They say Yokosuka Naval Arsenal did much of the work. They say the naval arm adopted the project in some form. They say production was planned for 1945. They say only about 125 rifles were truly assembled. They say parts for about 200 existed. They say 20 came into Allied hands at the surrender. They say the rifle suffered feeding and extraction faults in testing. They say parts broke. They say recoil energy and gas impulse were too low and too inconsistent in practice. Those lines are the skeleton of any fair retelling. If you write a documentary script from this, you can go back to the first scene. A crate in a yard. Men who want to make a thing that saves lives. A famous pattern on the table. A decision to change the feed to match what the troops know. A run of rifles that teach harsh lessons to men who already knew many harsh lessons. The war ends those lessons before the engineers do. Then the camera can move to a present-day room where 2 rifles sit under lights. A guide points at the operating rod on the American rifle, and then at the cousin part on the Japanese one. He shows a school group how a bolt rotates into battery. He pushes down on a follower in the box and shows them how 10 rounds would stack. He explains why an en-bloc clip did not live in this magazine. He explains why a top loading method mattered to men who had learned a different way to feed a rifle. He uses the words copy and clone very carefully. He says that the Japanese made a copy that ran like a copy and not like a twin. That is where the story belongs. Not in a taunt, not in a boast. In a line that any engineer would nod at. The Type 4 or Type 5 never made it past prototypes, because factories end wars as surely as armies do. The metallurgy and the tolerance stack told the truth. The truth was that the rifle demanded a kind of shop that did not exist in those last months. You can write one more scene if you want a small grace note. A range day in a quiet valley. A collector loads 5 rounds into a clip and slides it into a top opening. He pushes the second clip down. He lets the bolt run. He fires one careful shot after another. The rifle cycles. Brass jumps. At the 6th round, the rifle hesitates and then recovers. At the 9th round, the bolt rides over an empty space. The collector clears the stoppage by habit. He smiles anyway. He knows what he is holding is a bridge that was never finished. He knows that the men who built it were good builders. He knows that the river under that bridge was in flood. He puts the rifle back into a padded case, with more respect than most things earn. The moral that a student can carry away is not about who was smarter. It is about who had more time and more steel and more heat and more fuel and more gauges. It is about how a design is the easy part when the world is calm. It is about how the line workers become the deciding voices when the world is not calm. It is about how a nation that tries to copy a machine in a year of crisis will often learn that it must also have copied 20 years of shops and habits. Japan tried to copy the M1. What they built has its own name, Type 4. It is also called Type 5 by many careful people. The rifle promised simple function. The reality had too many edges. The feed looked clever on a chalkboard. Dirt and dust found its weak joints. The gas path looked fine on a clean bench. War does not hand out clean benches. The sum is simple. The project stalled. The rifle stopped at prototypes. The lesson did not. Copying is not cloning. A clone needs the same bones. It also needs the same blood. Here the blood was not there when the design needed it. That is the truth that survived the yard and the berm and the range and the museum glass. It is a hard truth. It is also a useful truth for anyone who wants to make a drawing do work. Subscribe for more untold stories of the Second World War.